Nice to see you all. I'm doing the class after some time. I didn't have the interaction with the children. So it's nice, always nice to see the children and, talk to you guys to know about the things. So let us have a two-way chat and, to get what is, I'll be going even, that don't think about the experience or anything which Sadish Uncle had said just now. It is, I will go into the basics of it. Okay, so one thing which I have learned in my life is that one, you don't have to for every complicated issue. Okay, if your basics are clear, there is no problem with that one. So I had a one mentor, Mr. R.K. Soni. He is the one who taught me. So when I used to ask very complicated question, he immediately starts with electrical and electricity is always with V is equal to, sorry, I is equal to V by R. Okay, so he always, any complicated problem, he starts with that one. So that is the time I realized, that if our basics are very clear, okay, we don't have to worry about that one. So this class it will be very basic, okay, to have your concepts clear, will not go into the too much complicated problems or anything. That once your basics are clear, you will be definitely able to solve all those things. Okay, so let's start with let me start sharing my presentation. Sadish, I need to the presentation.
In this system where your face is seeing, right? So that is made co-host.
Yes, I can share now. Okay, so the world of electricity, right? As you know that we cannot, if you are, even if in your life, you will be becoming a doctor or maybe an accountant or maybe a teacher or anything in life. But without electricity, you can't live, right? Everything, whatever you do, you need to understand what is, you will be using electricity. So it is good that whatever work of life you could take it, it is, that you to understand the basics of electricity. So before going into the basics of electricity, I want to just to touch base. How this history of electricity? Okay, how did we start with the, that human race? How did we start to discover about electricity? Okay, so the first in the ancient Egypt and all, in the Nile River and all, they had found some fish. Okay, which is they when they touch that fish, that it used to give some sort of energy to the, and it used to, so they call that fish as thunderfish. So that's an electric eel, which when it is that for it is his way of defending himself. So it gives that electric rays, and to that is to defend his enemies. Okay, so that was the electrical. This is what our ancient PMM here historian, they have found out, that they knew that there is a fish like this. It gives out some energy. There is some energy called like that. Okay, so they didn't know to name it electricity at that time. So this was the first incident. After that, they started absorbing the lightning. What is happening in the lightning? That lightning was there from long time, right? Millions of years it is there. So the lightning is coming. What is this one? So they didn't know what to, what was this, but eventually people started in 18th century, people started, researching, the scientists were there, they started thinking about it. And there was one in England, there was an Huxley, Francis Huxley named scientist. So what he did is he found out, he did an experiment, he found out when he did that experiment, there was a special kind of light which has come out of the glass sphere. So if you can see this one, what he did is he called all the scientists in England, because England was one of the scientific community in the world at that time. He called all of them, and he said he did this experiment. He, by switching off all the lights, he turned on this the glass sphere, and all the scientific community saw a special kind of light, a blue light, for the first time in the history. So then they also, there is some sort of energy which is coming out, and they tried to learn that what is, the people started, there was so much of research going in on 18th century about that what is this energy? And it was the Benjamin Franklin. Most of them considered him as the father of electricity. So what did he did a kite experiment, and he is the one who gave the that lightning and electricity, there is similarity. Okay, he did an experiment called kite experiment, in which he hold the kite, and the kite through the kite, and there was a string, and he attached his that key to that string. And if you see the string here, this is a conductive type of string, and this was a silk string where it was non-conductive. So the people who are touching that one, they don't get electrocuted. So, and with this, when he touched this one, he saw the spark coming out of that one. So that's how people realize that there is a similarity between lightning and electricity. It is something similar. Okay, so this is how the electricity, and from the 18th century, there was a lot of this one. And as you know, that Thomas Alva Edison, he found out the electric bulb. That was one of the biggest discoveries at that time. And we have what we have with electricity. We cannot live a single moment without electricity in our life. Right, we are here today with this one. Now, just a quick question on this one. Till what we have, you can put it in your chat window. Okay, what metal object did Benjamin Franklin tie to the kite to conduct electricity during the thunderstorm? Yes, Mega. Yes. Can everybody do it, so that that let us be interactive. Let us talk to each other and do it. Yes, very good. Okay, so it is the key, so which is a metal object, so that it can discharge. That's what Benjamin Franklin did it. Who discovered the similarity between electricity and lightning? What was the scientist's name? You can write A, B, C, D, no issues. Who discovered the similarity between electricity and lightning?
Benjamin Franklin.
Right, it is Benjamin Franklin, and he is considered to be father of electricity in many. And who invented electric light bulb?
Thomas Alva Edison.
Thomas Alva Edison. Okay, that all of you know. Okay, so this is what, just on the history of electricity. I don't know, have you seen this? Are you too good to see the Mr. Bean? Have you seen this scene in Mr. Bean?
Yes, sir.
Yeah, see that woman's hair? Why it is like that? Do you know why? What is the reason for that?
Static electricity.
What is that? Yeah, tell, it is right. Even if it's right or wrong, nobody is going to criticize it.
Is it static electricity?
Static electricity, that is right. Whatever it comes to your mind, so that we can talk about it, and it is good that it is static electricity. Now, you heard about static. Sometimes when you go and open the door, okay, you find you suddenly you feel that there is a shock on that one, right? Have you experienced that? Or maybe a doorknob or something like that. Have you experienced that?
Yes, ma'am.
Yeah. So that is another that another people had observed earlier. That is the static electricity. Now, what is the static electricity? Let's look into this one. Okay. This is the experiment in your textbooks and all. You will have it, and maybe if you can do it, if you have an amber rod and a small piece of paper, okay, if you rub, or maybe a fur and an amber rod, okay, if you rub that one, and if it normally, when you take the amber rod to this piece of paper, will it attract? Normally it will not attract.
No.
But when you rub this amber rod on a fur, okay, and then when you bring it to that one, it will start attracting this small pieces of paper. Okay, or maybe you can take this rod and rub it on your hair also, it will work. Okay, you can try it yourself and see that if it is working or not. So this is called, who's doing this?
1 second, what is the name of that person who is doing that? Who is good in geometry anyway? What is the name? Can you read?
Abhishek.
Abhishek, my dear friend. Come, where is Mr. Abhishek? Your geometry is good, we appreciate.
Okay, so this one, this is why it is attracting. That is the phenomena called static electricity. Let's see, has the scientific side, why it is happening. Okay, You know that an atom, you all have learned it, right? I think in 5th and 6th standard, now you learn it, that an atom consists of, in the central nucleus, it consists of protons and neutrons, and there will be electrons which will be going around it, right? So what happens, what creates the static electricity or the electricity, basics of electricity? Okay, so if you see this, this is an video model of this one. If you see, this is how the electrons move around. But sometimes with some elements, some atoms, this outside electron is very loosely connected. Okay, it is not that very strongly holding that electrons. Okay, so when you rub the amber rod on this fur, what happens? The electrons on the fur get transferred into the amber because it is very loosely connected. Okay, so that's how it can be, you know, that when you're rubbing it, that force is enough to remove that electron from there and it get transferred to the another particle. So that's what is happening. So in the normal case, in this, the rod and the paper, if you see the positive and the negative, okay, it is of the same. So it is a neutral item. There is no, it is not positive or negative, it is a neutral. So in this neutral fur also, it is the same. But when you start rubbing it, the electrons from the fur, you see the electrons from the fur, it is moved to the amber rod and it becomes a negatively charged item. And when this is negatively charged item, when you bring near the paper, it attracts that one. So that's how, why it is happening in the static electricity due to some reason, and during to the thunderstorm time or something, some energy is this electrons in that this one is getting displaced and it moves to the another object and it makes it negatively charged and it attracts other objects. So that is the reason why the phenomenon of the static electricity is happening. Okay, is that okay? Clear, right? Same thing with the, you know, that you might have tried with the, when you have the balloon, if you have the balloon and rub it on this one, you can see that, you know, that your hair will be standing out. Okay, it is the same similar way that when you rub the negative of you know, from the negative charge from your hair goes into the balloon and it becomes, since it's positive charge, it gets like, okay, same thing is that machine what you shown in Mr. Bean, that is generating like that, the machine which generates the, you know, that transfer of the electrons and it gets the charge. Okay, so now the question time again. So what is static electricity? What did you understand? Which is the one? A, B, C, or D? Yes, guys, in the this one, everybody to put it. What is the static electricity? Electricity that flows in one direction, electricity that is constantly change direction, or an electric charge on the surface, right? It is an electric charge on a surface of a object, right? An additional electric charge which is there. Right, that's good. So what atomic particle moves from one surface to another in order to form the static charge?
Electron.
Yes, you can type it so that everybody can participate. Yes, yes, that's right. I have 4, yes, electrons, that's right. Okay, so the atomic particle which is responsible for this charge is electrons. Okay, now we cannot imagine a world without electricity, right? Everything what we touch nowadays, okay, whatever we use nowadays needs one form or other form of electricity. Some of them we do in the plug, or sometimes we use the batteries or your watch. All have this all works on electricity, basic forms of the electricity. So maybe it is a small in your watch, you might be a small button type of battery might be there, or in your torch, or in your computer mouse, it might be the AAA. All of them are the source of electricity. And in our home, the plug is the source of electricity. So everything what we are using in our home, it is with electricity. So we cannot think about a day without electricity. Now, how does this electricity reaches our home? Have you thought about it? Do you know how does it reach? There is a long wave process which is that it reaches to our home, right? Our home, we know that when we plug, we are so used to it. When we plug, we want to do a kettle, or you want to do a microwave, you want to switch a light, you just switch it on and it is there in your home. How does it reaches our home? Okay, so there is a far, far away place. There is something called the power substations, that is the power generators. So where the power is getting generated. How does this power get generated? So the power can be generated by different, like they can use coal. There are a lot of natural resources which is used. Nuclear energy or gas or wind or solar power. Lot of available resources are there. And what happens is in this one, there will be big machines which converts the source of this coal or whatever it is. There's a process, it converts into electricity. And it has used large transmission big lines. You see these towers in whenever you travel to when on the road, right? Sometimes you see. So this will be travel long distance, maybe kilometers and kilometers. It travels and it might reaches to our nearby home. Now, when it reaches to our nearby home, there will be a substation which converts. You know, you might have seen that small transformers, maybe in Kerala and all, you can see that small transformers, but in other places, maybe it is inside a building which is kept. There is transformers. We'll go into the transformer details and all. This is from the transformer. What the transformer does, it is converts from a higher voltage to lower voltage or lower voltage to higher. We'll come to that one, don't worry about it. So from the transformer, it travels to the electric post near our line, or maybe it might be sometimes underground also, or maybe through the post on the road and the wire, and from there it reaches to our home. So when we switch on our light or fridge or TV or computer, it is there for you. So it is produced from far away distance and it is transmitted to our home. Okay. So this is how it reaches our home. So once it reaches our home, this is just for you to understand how the home connection, you know that when the electricity board comes in, when you're building a house and all, you might come across this one. You might see this one. There will be, whenever the electricity, this one comes, first it comes to an energy meter. Okay, that how much, because somebody is, there's so much of money to make this happen, right? There is so much of power station, people working behind it. So we have to pay for this, how much you pay for this energy. So first thing it is that you have an energy meter in your home. After that, there will be a fuse. Then after that, it comes to a distribution board. Here it is written as MCB box. That is where a lot of MCBs are kept. We'll get into details of that one. Don't worry. There is a box. From there, it is all connected to your lights, so your fans, your TV, and this one. And you can connect it to the control it by the switches. Okay. So this is how the electricity, once it reaches from the to our neighborhood, when it reaches our home, this is how it happens. It comes to an energy meter, then to a fuse. Sometimes we hear, right, that the fuse has gone and we have to replace that one. Otherwise, the current will not come in our home. The things will not be working, right? So like that, it goes into, it gets in, it reaches our home, and we will be using this. Okay, let's make a small story out of this one. So if you can, I think, put it in the chat window, this one. In dash, large spinning turbine generate electricity powered by wind, coal, natural gas, or water, the hydropower. Where does it does that one? Can you type in the chat? What is where it is getting produced? Water. What is that? Yes, it is produced from water. Yeah, that is written, right? It can be powered by wind, coal, natural gas, or water. What is that big building called? You know that what is produces that one? It can be produced. Yes. I think who has written? Yeah, the power station. Yes, that's right. So it is a power station. In Kerala, you might have heard about Idiki power station. Have heard about that one, right? So there, where it is produced, the power from the hydro power. So that is a power station. Next, the electric current is sent through dash, which increases the voltage so that power can be pushed over. I told you that, I think I didn't tell you this one. I'll explain this. So the current, when it is this one, where you know that it has to travel long distance, right? So there will be small substations which will be increasing the voltage to higher levels so that it can be transmitted to it can reach this, travel this long distance and come. So that you will see substations all over the country, all over the place. You will see lot of substations. Okay, look around. Is there any substations nearby your home? There should be something, some within few kilometers. There should be definitely a substation near your house. Okay, then this electric current is carried by dash held up by large tower. What is that called? You saw the large tower, and what is that one called? Wire. Yes, yeah, it is a wire. There is a specific name for that one, if you can heard about it. It's not what I've done it. So if you have transmitter.
Service.
What is that? We saw that one, right? I'll go through. I'll go through this one again. Okay. So, and there's the transmission lines. Okay, you saw that one on the tower. There is the that cable wires which is going. That is called transmission lines for the electricity which is coming. Then electricity connects to your house where it passes through a dash which measures the amount of electricity you use. What is that? This you should get it. Electricity to connect to your house, and it passes through a dash which measures the amount of electricity you use. Yes, Hrithikesh. Yes, anybody else? I have one answer from Hrithikesh. Amal, yes. Yes. Energy meter. That's right. So next, your task is find out in your home, where is your energy meter? Okay, go and see in your home. Every home has that one. Okay, without that, you will not get electricity. Find in your home, where is this electric meter in your home? Okay, finally, electricity travels through the wires inside the walls to the outlets and switches in your house, ready for you to use. I just want to go through the previous, this one. Just wanted to explain again. So it reaches to our power sockets where we can connect our equipments and we can use all of them. Where it comes from, it is generated in the power stations. Okay, electric power stations, big, huge places are this, and it might be a little bit far off and remote places. Definitely not in the cities. Okay, where the electricity is produced using coal, nuclear energy, or maybe natural gas, or maybe windmill, or maybe solar power. You have seen in the Cochin airport, right? It is produced with the solar power. You see the solar power when you travel there, you see all the solar power on that one. From there, see the transmission lines. This is the high voltage transmission lines, which I was telling you. Okay, so this transmission lines, it travels a lot of kilometers and it reaches our home. Okay, once it reaches our neighborhood, first it reaches to our neighborhood where it will have its substation, a small transformer, where neighborhood substation it is there, and it will be converted because it's coming in very high voltage. Okay, very high, maybe 11,000 or 24,000, but we use only 240 volt. We'll get into those details. What are these voltages and all? Okay, So then it reaches to the electric poles near our home or maybe underground, and it reaches to our home. Okay, so that's what the story of electricity, how it reaches to our home. Okay, so now we heard a lot about electricity, right? Now let us see, what is electricity? Okay, we heard in the static electricity, it is flow of, it is electrons when it is transferring, that is creating static electricity. Okay, so what is electricity is, it is flow of electrons. So you've seen the water pipe in your house, right? You see the water coming through the pipe and all. So in this one, so this is called current. In water system, current is the flow of water. Okay, so when we say in the water system, the current means it is flow of water. But in electric system, the current means it is the flow of electrons. It is the flow of electrons is called, or electrical energy, it is called the electric current. Okay, so that is what called current when we say. So if you see a normal, if you cut open a material, like for example, this is a copper wire. Okay, what happens in copper wire? It has a nucleus and it has the electrons which is moving around it. Okay, so what happens in a normal case? This electrons will be randomly moving around here because it is loosely connected. Copper is a good conductor. Okay, it is good for, because it has lot of, it is good conductor, it has lot of loose electrons. So what happens is when there is an, when a circuit is made. So in the electric current, you have to have always a closed circuit. If it is an open, the current will not flow. Okay, so you should have a circuit which is completely closed. Okay, and when it is closed, you will force the electrons to move in a pattern, and that results into electric current. Okay, you see this one? So this is how it's right now. It is randomly moving, and once it is, that force is given, we'll learn about those force. What is that force and all? It will be when it is when it is made it into a closed circuit. Understand? It has to be a closed circuit. That's called, when it is completely closed, it's called a circuit. So the electron will flow, and that is what the flow of electric current is. Okay. Now, you see, this is the water, right? You know that if the tank, can you tell me, will the water flow? In which figure will the water flow? In the figure 1 and figure 2? Okay, you see this one? There's a small difference between both of them, right? So what happens? In which one the water will flow? Yes, Ritikesh, figure 1, yes. Mega figure, yes. Who else? Now tell me, why do you think that why the water will not flow in figure 2? Why the water, anybody who can unmute and tell me that, why the water doesn't flow in the figure 2?
Because of less amount of water.
Less amount of water, but there is water, right? Why it doesn't flow? That at least they can flow. Yes, I think Ramil knows this one. It is because there is no potential. There's something called potential energy. Okay, it has to have that energy so that it will force this water to flow. Okay, in the second figure, because it is both at the same level, it doesn't have, it is called potential energy. There's some sort of energy which is due to the height of this one, it is created. Okay, because there is no force to flow that one. In the second figure, it is not flowing. So you know that water will flow only if there is more height, which is called more potential in that one, and then only it will flow, right? Similarly, for the electric current also, you need this potential, so that electrons can flow in one circuit. Okay, this is a closed circuit. Right, it is not at all open in any place. It is completely closed. Even in the electric bulb, it is continuing. And so what is this electric potential? So this one, the cell here, the battery here, that 1.5 volt, that is, you have seen the batteries for all your equipments, all your toys, you need these batteries, right? So what it gives, it is a potential energy which is given so that electric current, it will force the electric current to flow. Similarly, like at this tank, that height of this one creates an energy which will allow the water to flow through this pipe. Okay, so this is what the current. So to current to flow, you need this potential energy to go. So this is what is happening in this circuit. It will not just, if you just connect the wire and do it, it will not flow. It doesn't have any force to make it flow. So what happens? There is a battery. That is giving the potential energy to flow to enable the flow of the electrons in this. Okay. So this is a water pipe. Okay. What happens in a water pipe? When you push the water through that one, it will flow. But when you push and push and push, what happens at certain point of time? It might, if it is more than the capacity of this pipe, what happens? It might burst, right? That's what you sometimes hear, right? It is the pipeline is broken because it is having more water than it can carry. Similarly, in the electric current, what happens? If you go on increasing and increasing this current in the circuit, what happens? The circuit, it will not be able to take up this one. The wire is not capable of taking that many of electrons. And what happens? The circuit might blow off. So that's why sometimes what happens, sometimes the current comes, some malfunction happens in your equipment or maybe in the fridge or in the TV. And sometimes what happens, the current increases tremendously and the circuit will burst off. That's what it happens. Sometimes you say that it is bursted. Okay, so this is what it happens. Now we learned about lightning, right? What about lightning? What happens is it's too much of electrons in that one. Okay, we cannot imagine how much of electric current is there. It is thousands and thousands of the volt of electricity is there in the and that much of electrons will flow through that one. So have your parents tell when the lightning is there, switch off the TV, don't use it, and all? Your parents they tell you?
Yes.
Right? Yes. Okay, why do they tell it? What happens is, so when the lightning strikes, okay, if by any chance it strikes your home, okay, so it might strike your the wire. What happens? It's too many of electrons which is coming, right? So it comes to your home and it goes through your TV or whichever equipment is connected, and it will completely burst off. Okay, so that is the reason why your parents tell during the time of the lightning, don't switch off which is connected to the electric, because if by any chance your home is hit by the lightning strike, the lot of electrons will flow through your circuit in your home and all your equipments will be burned out. Okay, it has happened in my home also. My TV has been gone, and always my parents also used to tell this one, and I don't used to like it at that time. I used to think they are simply saying, okay. That's what I used to think. And when one time when we lost this one, we knew that. So this is, so let's go for a small interaction section. So what's an electric current? What is an electric current? Potential difference between 2 points in an electric circuit, rate at which electrical energy is transferred, flow of electrical charge, flow of atoms. Yes, you can put ABC. Yes. Megha, Tikesh, Anjana, Amal, Navajit, Abhishek. Yes, all of you know that's flow of electric charge. This is the electron. The flow of electrons through a wire or any conductor is called the flow of electrons. What is that called? It is electric current. All are quite smart. Yes, everybody knows that is called electric current. Now, a closed path through which electron can flow is called, told you that is a closed path. It has to be closed path, otherwise it will not. What is that called? That closed path? Voltage, circuit, conductor, or current. B. Yes, that's right. It is so electric current, this one to flow, you have to have always a closed loop, that is called a circuit. Okay. Now you looked into the voltage. So just wanted to for the river to flow. Okay, if the river to flow, if all is at the same level, okay, will the river flow? In the swimming pool, does your water flow? Have you
No.
seen it, right? You're not seeing the water flow. It is by forcefully by the machines and this one. But in the river, you have seen maybe you know that when you've gone for the maybe a different I don't know. I have seen the near Adrampalli and all that river. When you see the water is flow. Why does it flow? Okay, if it is at the same level, it will definitely not flow. But if the level, there is a level difference, then only it will flow from one level to the other. So what happens if it is, you know, that one level is very high and one level is low, then the water will flow according to this height, it will be very high. So that is what in the electricity, we call it as voltage. So you can definitely compare with an, you know, water tank, which is filled with water. And you can, what we say when there is more water, in water, we say that it is with high pressure. Okay, so when the water quantity is low, we say it as low pressure. Okay, so in the first one, it is high pressure, and the second one, it is low pressure. Similarly, in the electric current also, that we can have this voltage. Okay, this is at higher voltage. This bulb will be working at a certain particular light. But if this voltage is increased, it will have more electrons flowing through that, and it will give more light. So the flow of electrons, to have to make it flow, it is called voltage, and that is the force which it needs to flow of the electrons. So when you increase the voltage, more electrons will flow. Okay. Now, which is another term used for voltage? What does it mean, the voltage? Resistance, potential difference, and current.
Potential difference.
Potential difference, right? So that is, you know, whenever there is a potential difference, then only in the water also it is called, you know, the potential there, it is there. And current also, if there's a potential difference, it is it can flow. So in electricity, the potential difference is called voltage. Okay, so what is a voltage? It is electrical potential difference. I think we did it. Okay, now next one. Now you know that we told about that electrons is flowing through the through each elements and all. What happens when the electron is flowing? Okay, sometimes what happens? It is, you know, the material which is flowing. It gives lot of force. That, you know, that it obstructs this electrons flow. Okay, sometimes, for example, if you see the iron, it has more obstruction, but in copper, this can go very easily. Okay, so what is this obstruction called? So if you see in the water, if there is an, you know, there is some problem with the pipe is bent, or maybe if some, you know, that it is clogged, you know, there is an obstruction, the current, so water will not fully flow through that one, right? In a water pipe. Similarly, in an electric current, okay, we call that obstruction as resistance. Okay, if you see in the previous this one, okay, that is, it is the electron flow is obstructed by that element. So that is called resistance of an electric circuit. Okay, what is the which is obstructing the flow of electrons. Okay, that is what resistance. So when you learned about the resistance, so it is, what is its duty? Resistance is what it is doing. It is obstructing the flow of the electric current in an electrical circuit. Okay. So now let's look into the resistance. The resistance, like for example, copper might have a different resistance of its. Tungsten maybe have different resistance, or any aluminum may be having different resistance. So it's all the elements, because all the elements are made up of different atomic particles, right? So for example, copper is made like this. So you see this one, the force of this, the external electrons. Okay, we told you that the electron has to freely flow. Okay, so because the copper is having less, you know, that less force binding the outside electrons, it will easily able to flow that electrons, and electrons will flow through the circuit. So copper is considered to be a good conductor because the resistance of the flow of the to making that free electrons is less in copper. But if you see the tungsten, it's having the force is so strong of the subatomic particles, the electrons cannot be freed so easily. So that's how some elements, some materials are good conductors, or maybe some materials are bad conductors, because the electrons are not freely available in that case. So for example, in this one, if they see same cell, if you put the same voltage here, and if I use copper wire and if I use tungsten wire, what happens? Copper will have more electron flow and it will give more light. But in case of tungstens, the electron is very, that it's not easy to get the electron flow. Even with the same amount of this one, it will not easy. So what happens is the light produced by that one is low because the number of electrons flowing is low in that one. Okay, so what you understand from this one is the resistance, it depends upon the material. The resistance, okay, so like the copper has one resistance, tungsten has one resistance, aluminum has one resistance, iron has one resistance. So depending upon the material, the flow of electrons have their resistance to the flow of electron is resisted by the type of the material. Similarly, like when you increase the length of this one. So for example, in this one, okay, this electron has to travel only this much. But what happened? This electron has to travel this much distance. So what happens? So if the length is less, resistance is less. If the length is increased, the resistance is also increased. Okay, so it has to travel, it has to overcome more power to reach to the other this one, and there will be more resistance of this much obstructions are there for this electrons to travel. But this electrons will have only this much obstruction to reach to the other end. So the resistance depends on the length of the material. Next one, what happens if this one, if I increase the area cross section of this the circuit, the wire which is used, if I increase the cross section of that one, my electrons has lot of area to flow. If the area is increased, I have lot of area for the electrons to flow, right? So what happens? The electrons can flow so easily. So what happens if the area is less? Okay, there is more resistance. Once the area is increased, the resistance for the electron flow is less. Okay, so what we learned is that resistance according to the material, it directly depends upon the copper. Then if it is the length, if length increases, resistance increases. Also, when the area increases, the resistance decreases, right? It is not equivalent to the length. In the area, when it is getting more, it is more free. There is less resistance for the electrons to flow. So that's what. I don't know if you have learned about this one, the resistance. So that's just what say resistance is dependent directly proportional to the material, type of the material, and directly proportional to the length, and inversely proportional to the area. So this is how this formula is coming. R is equal to rho L by A. So this is, you can find out the resistance, or any circuit if you're given, you can find out if it is, and you can say that one, what happens when the resistance is increased. We'll learn all that one. This is just the basics. What is the resistance? So resistance depends upon the type of the material, to the length and the area. Okay. Okay, now the question time. The resistivity of a wire depends upon length, material, cross-sectional area, or all of the above, right? Somebody has put A, so only maybe depend on A, all of the above. Yes, it depends upon length, directly proportional to the length, directly proportional to the material, and the cross-sectional inversely proportional to the cross-sectional area. So the resistivity of the wire depends upon all of the above. Now, what is a resistance? What is a resistance? A resistance, is it a flow of electrons, or is it an electric potential difference, or is it a type of a battery, or an ability to reduce the flow of electrons? Yes, ability to reduce the flow of electrons. Mika, you're fast in typing. Yeah. D. Okay, that's right. Okay, so the resistance is the ability to reduce the flow of, it is obstructing the flow of electrons in a circuit or a material. It is getting restricted. So now can you tell me, how could you decrease the resistance of a wire? I want to reduce the resistance of a wire so that more electrons can flow. Which one I can do? Increase the thickness of the wire or decrease the length of the wire or use the material with higher resistivity? Decrease the resistance of the wire, increase the thickness of the wire. That's right. I think the decrease the length of the wire will also reduce the resistance, right? I think I had two answers in this one. Okay, decrease the length of the wire also will reduce the resistance of it. If it is 10 meter, there is a particular resistance. If it is 20 meter, sorry, if it is 5 meter, the resistance is reduced, right? Because it is directly proportional to that one. Okay, so I think I was supposed to write it. I think I made a mistake here. It is both A and B are correct in this one. Okay. Now, so you have learned till now the basic concepts of electricity, current, voltage, resistance, and all, right? So this is the basics. Now, voltage in our everyday life. This is a quick one. You might have seen in your iron box, right? Can you see what is the voltage in this one? What is, can you read it out? It's an iron box in my home. So what is the voltage in this one? Can you read it out?
240.
Yes, 240 volt. You see this one? This is the, every equipment in our home will have this voltage. Okay, so 240 volt. Now here also, this is the electric bulb. Here also it is written, it will work with a voltage of 220 to 240. There is no problem for them to work between 240 and this is the TV. If you see in this TV, you can see something different. You see the, what is the voltage here?
100 to 240.
So it can work from 100 volt to 240 volt. You know why? Do you know why it can work on 100 to 240? Because in India and all, we have 240 volt. Here also, this is the laptop, 100 to 240. You know, in the world, there is, okay, so before I go into that one, just when you come for the next week, I want you to do this small exercise for me. Just find out from the 5 equipment, what is the wattage and what is the voltage of that equipment in your home. Any 5 equipments, maybe a fridge, maybe a microwave, maybe an electric bulb, or anything in your home, or your TV. See how much is the wattage. There is, you know, that watt is written. You see this one, 200 watt. There is a figure 200 watt. Here also it is written 200 watt. In the light bulb, it is written as 23 watt. It is so small. Okay, and the iron box, it is very high. It is written as 1200. So find out in your maybe same equipments in your home, what is the wattage and voltage in your all these 5 equipments, any 5 equipments. Okay. Now I told you that in the TV you saw that one, it works from 100 to 240 volt. Why like that? Because in the world, everywhere it's not used our 240. In Kerala, in India and all, we use 240 volt. But if you see in the world, all these blue color countries, it is using 240 volt. But if you see in this red color countries, it use only 110 volt, 110 to 120 volt. That is half of our voltage only in use. What happens? Okay, why this one? Now, for example, if you had a cousin in your US, okay, if they come from US and they bring their equipments, can they plug it into our plugs?
No.
No.
What happens?
Supply increase and they will make a shock.
So what happens? I told you, right? If the voltage is increased, the amount of current flowing to that one will increase. So, but this equipment is not designed for that one. This equipment is designed only for 110 volt. So what happens if the same equipment you plug it into a 220 volt supply? What will happen? It will all burst out. It cannot be used. Now, if from India, if we go to America, can I use my this one? Can I use my hair dryer there?
No.
what
No.
happens?
The power will be reduced and
Yes, that's right. Okay, so what happens? So this is what will happen here. Now what happens? My 220 volt, I take it from India to US. What happens? It is designed for some, that's 220 volts, that some amount of the electrons to flow, then only that will function properly. But what happens when you go there? It will not get enough amount of this one. It will be working maybe at half the capacity. Okay, so for example, you see the water. In this one, the water, the electron flow is like this. But in this case, it might be coming like this. So you know what happens? It will be working with a very less power there. Okay, so that is how the voltage is. So with this, I will conclude today's session. So we learned about the history of electricity, how in the ancient world itself, we knew about this electricity, but it was, and then in 18th century, there was a lot of experiments and they knew about this one, lightning, and all the experiments were done. And here we are today with all the usage of electricity. And without today, we cannot think about this one. We learned about how the electricity reaches our home, and we learned about the basic concept of electricity, that electricity is 3 parameters you need to know. Okay, one is the current, one is the voltage, and one is the resistance. I hope that is concepts are clear to you. That is, the current is the flow of electrons. Voltage is the potential energy which forces the electrons to flow, and the resistance is the obstruction created by the material through which the current flows.